Hello everyone, welcome to the webinar, a joint webinar conducted by Altizon Systems and the Industrial Assessment Center at West Virginia. Today's topic, IoT-enabled energy conservation. We'll be covering every aspect of how IoT can help you conserve energy and how energy audits would be the first step towards achieving the required conservation goals. So before we begin, a quick introduction to the panelists today. We're honored to have Dr. Bhaskaran Gopalakrishnan, also popularly known as Dr. Gopala, who is the Director of Industrial Assessment Center at West Virginia University. He is a certified energy manager and a U.S. Department of Energy qualified specialist in the areas of compressed air, process heating, fans, and steam systems. Pleasure to have you, Dr. Gopal.
Thank you very much, Harish.
We also have Mr. Amol Mate, who is the Vice President of Industrial Business Unit at Altizon Systems and also a Principal Consultant for IoT Solutions in Manufacturing. Amol is also joined by Aditya Rikhari, Senior Business Development Manager at Altizon Systems. And this is Harish Kulkarni. I'll be moderating today's session. Once again, thank you everyone for joining us. So, as we begin, let's take a quick look at the stats. Typically, heating, ventilation, and air conditioning systems constitute about 24% of energy used in manufacturing facilities, which is about 1/4. And according to US Department of Energy, manufacturing plants can often reduce HVAC cost by up to 15% by implementing energy-saving measures and best practices. So with HVAC accounting for more than 1/4 of energy used in manufacturing sector, any savings in this area will surely make a big impact. So there are two terms that are synonymously used and often confused, which is energy conservation and energy efficiency. These are different but related, and let's take a quick look at what it means. So energy efficiency is typically using technology that requires less energy to perform the same function. So a simple example would be using an LED lamp that requires less energy than a CFL to produce same amount of light. And energy conservation is any behavior that results in use of less energy. For example, turning off lights when leaving a room or recycling aluminum cans are both ways of conserving energy. So we'll be covering both these aspects in today's presentation. So without much delay, I'll hand over to Dr. Gopala, who would quickly introduce us to what IAC is and how energy audits can be the first step towards energy conservation. So over to you, Dr. Gopala.
Thank you very much, Harish. As Harish mentioned, I'm the Director of the Industrial Assessment Center, which is a Department of Energy funded program. We are in the 26th year of the program, and we offer no-cost energy assessments to manufacturing facilities that qualify in terms of their operating characteristics and system characteristics. So our efforts are into determining energy efficiency, water and waste reduction, smart manufacturing initiatives, and also cybersecurity threat alleviation. So we have existed for a long time, 26 years, and over those period of years, we have done an energy assessment for several facilities, as you can see, and we have recommended significant energy savings annually. A lot of it has been implemented as well. So if you go to the Industrial Assessment Center database, you should be able to find out the performance in terms of energy savings recommended and implemented for the Industrial Assessment Center program and specifically for WVU and other centers. So most of these recommendations have a good payback on investment, and they are targeting the low-hanging fruit mostly, but also we do some innovative recommendations that involve cogeneration, chillers, and CHP units, and so on and so forth. So we are very pleased to be a part of this webinar, and Amol Mate is one of my students, and we are very happy that he has done well in his career, and we wish him the best moving forward in his career. So the next slide, please. The HVAC equipment is invariably related to the chillers in most cases, and the chillers could be multiple stage chillers, or they could be single stage. But nevertheless, one of the biggest problems is that when you have chillers is whether they are underloaded. Now the load parameters might be acceptable for the motor, but they may not be acceptable for the chiller. The reason is that the chiller load depends upon how much of the cooling load it is addressing in terms of its operation. And if it's going to be on a part load, a small load on a chiller is devastating in terms of energy usage. And there is a potential here, if multiple chillers are used, that they can be sequenced and they can work together in order to produce energy savings by having them each operate at a higher load, and hence, based on the load characteristics, the energy efficiency can be increased. Variable frequency drives definitely is an option in these motors that operate these chillers, and the way the compressors are operating, and we often recommend that in most cases. In terms of a cooling tower, sometimes the chiller system with the HVAC has a cooling tower associated with it, and if so, we definitely take a look at the cooling tower fan and also the liquid movement in the chillers as well as the cooling towers, what type of pumps and the heat transfer surfaces and so on. So we try to get an idea about the chiller operating profile and the pipe insulation and the load, and we do some measurements as well to be able to ascertain these parameters. But what we do is mostly on the day of the assessment, and it's probably going to be a snapshot type of measurement, maybe over a few hours. But I think what would benefit the HVAC system and the chillers would be a more continuous measurement and trying to look at the efficiency over time, which I think is something that would be very beneficial on the continuous improvement level. Next slide. So we do measure, and the measurements, as I said, are more like a snapshot. We may, in some cases, leave the electrical measurement loggers and transducers on for a few days, but there is no substitute for continuous measurement. That is what would be ideal. But anyways, we would measure the current, the voltage, the power factor. We would also measure the flow rate, right, of the medium. We would definitely do that, as well as the temperature differences. So that tells us a lot about the load profile, the part load profile of the chiller. And the COP of the chiller can be estimated, and based on the COP understanding and the part load profile, we can arrive at a reasonable conclusion on how much energy can be saved by improving the load characteristics of the chiller. So the data logging is an important part of it, and more continuous that it can be done on chiller systems, better off we are in trying to understand its behavior with respect to parameters such as production changes, weather changes, and other kinds of aspects that will affect the performance of the chiller. Next. So we have recommended over the period of years several energy conservation measures for buildings. Yes, HVAC associated with buildings as well as manufacturing plants, and those would be related as an example to reducing or increasing the chiller set point. So that's what we mean by chiller water supply temperature control. So for example, if a chiller system is operating at 38 degrees Fahrenheit, and we think that maybe bumping it up a couple of degrees to 40 will not affect the process based on discussion with plant personnel, then we would definitely try and do that in terms of a recommendation and see how much energy can be saved. And the sequencing of it and then the condenser profile can also be looked at in terms of temperature set point. The sequencing, as I mentioned, occurs when you have multiple chillers and multi-stage chillers, and we take a look at the load profile in terms of sequencing. What a sequencer essentially will do is to try and run these chillers at as maximum load as possible, and then possibly suggest ways of trimming the final element in the chiller system so that we can try and reduce the energy consumption. Now when it says to trim, sometimes what may happen is that the chiller that is trimming might be very much underloaded. So that opens up a situation of load sizing of that chiller. Maybe it is too big for operation under these constraints of the manufacturing parameters. So that opens up that possibility of thinking about downsizing that chiller. Of course, maintenance is important because all of these chiller and HVAC systems have heat transfer surfaces, and heat transfer surfaces have to be cleaned. They have to be maintained regularly. Otherwise, you lose the heat transfer effectiveness, and hence the energy consumption also would increase. So what we find is that there's a big opportunity here to look at chiller systems, and 5 to 25% of the cooling energy can be saved usually. And if you raise the chiller water temperature, yes, there is significant energy savings, and this condenser as well. So these are some of the things that one can pursue, but it does take measurement. So without measurement, you really cannot do a whole lot, because we may end up giving a recommendation on that day based on just observation, which may not be true over a period of time when production changes, weather changes, and other parameters change. Okay, next slide. Okay, thank you.
Thank you, Dr. Gopala, for these insights on how critical it is to take that first step in terms of measurement and understand the real consumption patterns. As you rightly mentioned, continuous monitoring and measurements is very critical to achieve the desired goals in energy consumption, energy conservation. And with that, I would like to quickly pass on to Amol, who would help us understand how IoT can help you in continuous measurement and analysis of the required parameters. So over to you, Amol.
Thanks, Harish. I'll start with a quick introduction to Altizon. The slide which you see in front of you shows the use case distribution of the different initiatives which we have worked on across around 62 manufacturing plants so far. And you will see that quite big chunk, around 35 out of those 62 plants, we have worked on different aspects of energy management and energy conservation. And the idea being listen real time to the heartbeat of the devices which consume energy, or the equipment which consumes energy on the floor. And as Dr. Gopala mentioned, that continuously monitor and measure the parameters, and then create opportunities for improvement in terms of downsizing or any other energy recommendation. The system also helps you to sustain that recommendation and continuously validate the savings which were generated over time. Next slide, please. Right. So a typical IoT or Industrial Internet of Things world is divided into two parts. One is the hardware side of things, and the other being the software or the platform or the data analytics part. So on the hardware side of things, there are plants which have legacy equipment which are not equipped to talk to a software platform or an IoT platform, and you might also come across very recent and modern equipment which are ready to send data to some platform or a common source. The typical journey is that we do an assessment of the shop floor and identify critical to energy assets on the shop floor and try to understand if the equipment is capable of sending data to the platform. If it is not able to do so in its current state, then we might end up putting additional hardware sensors, if any, capture that data, log it into some local data logger in the plant network, and then push it to the cloud-based IoT platform. Once the data comes to the IoT platform, then we try to look at it more in terms of business point of view and see if we can define logic and try to generate recommendations for improving energy and conserving energy. The platform also gathers data about production, quality, and other environmental variables, and as a result we have a common data platform where we are able to correlate these different variables, and that normally generates very wonderful insights and strong correlations between production, energy, and other critical variables on the floor. Next slide, please. So coming to chiller systems efficiency, and as Dr. Gopala mentioned, that typically there are 3 or 4 major recommendations which come out in a energy audit. So in this slide, what you see is that we have tried to show the diagram in which we can put sensors in the system. So if you see here in this slide, the black, these are the temperature sensors which can be deployed at various points in the network, and once this sensors start sending real-time continuous data to the platform, then we can develop logic in the platform to generate notifications and control this system almost in real time and continuously, so that I can conserve energy based on continuous real-time data and also take corrective actions based on the data. So the way it is structured is that once these sensors are deployed in the network, through a gateway, the data is sent to the Datonis, which is our IoT platform. And what you see here is a MQTT kind of protocol being used, wherein we get an opportunity to remotely control the system if the rules are violated, right? And I'll show you a demo around this. Once the data lands into this Datonis IoT platform, then we can have analytics run on that data and get further insights in terms of correlations between different variables. So I'll switch on to the demonstration. Before I move there, we'll pick up this first slide where Dr. Gopala mentioned that one of the recommendations in improving chiller system efficiency can be looking at the chiller supply water temperature, right? So in this case, if we are able to monitor the cooling load real time, and when I say cooling load, there are different ways in which we can monitor the cooling load real time. We can actually measure the outside dry bulb or wet bulb temperature. We can actually look at the number of people in a confined space based on their entry-exit points real time. And with help of ASHRAE tables and logic built in the platform, we can very accurately establish the real-time load for that particular geolocation. Once that cooling load is established based on this different criteria, then I can look at the real-time chilled supply water temperature, and if there is a case to increase that temperature, then we can remotely do that real time without any manual interference. The idea being that for a reduced cooling load, if I increase the chiller supply water temperature, then it will result into less work for the compressor and then hence energy saved. So I'll switch over to a demo wherein we'll be able to see this, how this data comes in and how we are able to do it. So what you see in front of you on the screens is the Daytonis IoT platform, where in IoT world, industrial Internet of Things world, we define this chiller system maybe as a thing or a system which has different metrics which we want to monitor real time. So what we have done here is that we have taken a chiller system and defined different parameters which I want to monitor real time from different sources, which includes the sensors or the PLCs of the equipment out there. Once this definition of the template is established, then actually I start streaming data to the platform for each of those metrics. So what you see in front of you is the real-time data coming for those different parameters of that particular equipment. Now, once we get this data real time, then we see an opportunity to define logic, rules, and then set notifications and send instructions to the control system of that particular chiller system if a particular rule is violated. So in this case, what we have done is that we have tried to simulate data wherein if I do an audit of a classical manufacturing plant which has a very high HVAC requirement, and with IoT and post IoT, how would it look like, right? So what you see on your screens is that we have simulated data for a certain time period, and you will see that the chiller water supply temperature and the set point is varying in this particular graph based on the actual load of that particular zone. Idea being that with change in load, the chiller supply water set point is changed so that the comfort level of that particular zone is maintained. What it will do is that it will throw out what was the energy consumption. So what we have done here as a simulation is that what was the energy consumption if you are not doing real-time energy monitoring, and with an IoT enabled energy monitoring initiative, you can see here how I'll be able to save kilowatt hours consumed during a particular period, right? So you can see these different graphs and mashups as we call them. Now the real beauty of the IoT system is that I can set different rules, and just as a demo we have set one rule here, chiller water set point. So what I can do here is that I can set rules for the different real-time incoming data and actually select the appropriate metric and define a rule which will in turn trigger a notification, right? So I can go to a notification and it will instruct the chiller system, the hardware, that it needs to do some correction in the set point temperature based on the data which is coming from the platform. So this instruction can be set which will directly talk to the control system of the equipment and do the necessary changes real time. So the power of the platform is in monitoring data real time and communicating back or controlling the device real time so as to get real time energy conservation savings. Let's move to the presentation. So the same thing can be replicated for a chiller system which has a cooling tower as part of the system, and in this case I'll be able to monitor the wet bulb temperature around that cooling tower, and based on that we'll be able to monitor and control the condenser supply water temperature, and hence it directly has an impact on the compressor work and the power required. We understand that there is a limit to this particular recommendation, and typically if the temperature, wet bulb temperature, is below 75 degrees Fahrenheit, then you may not end up saving a lot of energy, because I will start consuming more on the motor side of the cooling tower. So all those rules and logic can be established in the platform so that we have the correct and appropriate energy recommendation going and the appropriate control happening in the system. So we are able to take a systems view through this, because I am able to look at data points from the different components of the system and then look at it more at a global level and then make a recommendation which is good for the overall system. Another very important benefit of doing an IoT implementation energy management point of view is real-time condition-based monitoring of this equipment. As we all know, there are various critical parameters in the chiller system network which are important from efficiency, maintaining the efficiency point of view. So if you see on this particular slide, we have mentioned certain critical parameters like LMTD of compressor, condenser, mass flow rate of refrigerants, volume flow rate. So we can have individual sensors for each of these critical parameters, and those critical parameters of the equipment will be monitored real time. Obviously, the idea being that, say example, if a particular flow rate is critical for the performance of the equipment over time, we are able to define upper and lower control limits for that particular parameter and a target value, and monitor the actual value of the equipment vis-a-vis that set limits. So going back to the demonstration, what you see here is that we have again tried to put in few critical parameters for a compressor and a chiller. And what you see here is that are there any points which are outside control limits, or are the points within the given control limits? So if you really get into Six Sigma kind of a language, then what we are talking is that if the process capability of this important critical parameters of the machine are in statistical control, when I say that CP, CPK point of view, then the likelihood of an unplanned failure of that equipment is very low. At the same time, I am able to generate rules and again alerts if my critical parameters are going out of statistical control, and alert the maintenance team to take real-time corrective actions so that I save on the equipment, spare parts and downtime, as well as make sure that the energy efficiency is maintained at the desired level. Right. So this is what I wanted to cover. The advantage of getting all this data onto the platform over time is that once the system is connected and once we have this data coming in for a period of time, over a couple of months, the same platform is also used normally to book your production data real time, and then that is where we are able to use platform's capability to do very detailed analytics in terms of adopting machine learning and other algorithms to find if there are correlations between this data and if it is possible for me to generate additional insights and actionable insights from the data points. I see that going in future with a company like Altizon, which has a very proven IoT platform, and domain expertise like Dr. Gopala and his team at IAC, we see a very strong opportunity to collaborate, wherein we are able to bring in the hardware and the technology to capture this data real time, and with the domain experience of team like IAC, we are able to build this logic and derive next level of energy conservation for the clients on a sustainable basis. Thank you.
Thank you, Amol, for your insights on how IoT can enable real-time monitoring and conservation of energy. So we have quite a few questions coming in from our audience today. So I guess the first question is, how can IoT help a typical manufacturer in the US to comply and sustain with ISO 5001? So Amol, we were discussing this earlier today, ISO 50001 being a very critical factor moving forward from the compliance and regulatory environment point of view. Can you please take that question?
Right, and I think Dr. Gopala is the right person to address that, but is he out there or should I take that?
You can take that.
Please go ahead, I'll let him know, he'll be here soon.
Okay, so ISO 50001 is the next generation energy management standard which is coming in, and as part of the standard, it will become mandatory for manufacturing plants and industrial facilities to set a target over time and make sure that energy is monitored real time and the company is monitoring real time and achieving the target and sustaining those savings. So if we go through the standard, it's a very stringent standard in terms of making it happen on the floor. And the way I see it is that IoT platform like Daytonis will actually completely help in energy auditor and ISO 50001 auditor to look at before and after data in terms of what was the scenario before we did this implementation, and are we able to sustain that implementation over time if there are any gaps, and it will be monitored real time. So I see a lot of importance of IoT platform in getting ISO 50001 certification for a particular plant.
Thank you, Amol. There is another, there are quite a few questions coming in, and in the interest of time, we'll take this as the last question, and other questions we'll answer by on an individual basis by emails. So the question is, how can one go about monitoring this and connecting the hardware that is available in the manufacturing facilities, and what all entities are involved in doing this?
Right, so Amol here. So as I indicated earlier that we typically end up doing an assessment of the plant in terms of the technology readiness to deploy IoT or make the plant IoT ready. Our experience is that modern manufacturing plants have good capability to stream data to the platform. There is some tweaking required and some hardware required to be deployed. But we have also connected legacy plants which had legacy equipment, and the control systems were really not upgraded to a level to send data to an IoT platform. So we take up that challenge to get that data, put it to a local data logger, and then send it to the platform. There is no one right answer here. Based on the technology readiness of the plant, we have to identify the bill of material required from hardware point of view, and then deploy that hardware and then start streaming. The question also mentions about pricing, and obviously the pricing and will change country by country. Fortunately, with IoT, there is a lot of innovation happening in sensors, and every day you find a new innovative sensor out there to help you to connect and get required data from the system.
Thank you, Amol. Thanks for that answer. I hope that answers the question. So we have, as I mentioned, we have quite a few questions coming in, and we'll be addressing those on a one-on-one basis by emails. So please stand by and expect an email soon from us in your inbox. So with that, just to conclude, IoT plays a key role in understanding the real-time condition of your assets, and energy audits would be the first step towards that journey for energy conservation. So thank you, everyone. Thank you, Dr. Gopala. Thank you, Amol, for presenting those valuable insights on the steps towards energy conservation and compliance with the regulatory rules. So a quick overview of where you can connect with us. You can always reach out to us on sales@altizon.com, or you can also follow us on Twitter or LinkedIn. We are available at the IoT World USA conference in San Diego on 20th and 21st of Feb. And we are also present in the American Manufacturing Summit in Chicago in March 2017. So if you're in that area, feel free to drop by and meet our experts and get all the help necessary in your effort towards energy conservation. Thank you so much, everyone, for joining today's session. I hope this was helpful, and we look forward to hearing from you. Thank you. Have a great day. Bye-bye.